This video is on Unit 2, Chapter 6, Quadratics Extras, Lesson number 4, Quadratics, Standard and Vertex Forms. In your notes here under Standard Form and Vertex Form, standard form of a quadratic function is f of x is equal to ax squared plus bx plus c. Vertex form of a quadratic function is f of x is equal to a times x minus h squared plus k. Now, your vertex form should look similar to that generic formula or equation I gave you back in parent functions, where the a tells us whether or not the function stretches or compresses. The h is a horizontal shift, but remember it lies to you. You're gonna see here why it's lying to you, and then the k, which is your vertical shift up or down. Your vertex is HK, and then your axis of symmetry is just going to be x equals h. And then when we're converting from standard form to vertex form, it is similar to completing the square. Similar to, but not exactly, but very similar. Vertex form to standard form is basically order of operations. It's just basically order of operations that we're going to be doing here. Number 1 says to square the binomial. Number 2 says to multiply a by the trinomial and then combine your like terms. But if you can remember just order of operations, then that's what this is going to be like. So in example number 1, it says f of x is equal to x plus 3 squared minus 12. So basically what we've got here, it says to take the x plus 3 and square it. Remember, exponents come first. So I'm going to do that first. I'm going to leave this minus 12 just kind of hanging out for a minute. X plus 3 times x plus 3 is going to be x squared plus 3x plus 3x plus 9, and then bring down the minus 12. So at that point, we just need to combine our like terms, and we get x squared plus 6x minus 3. Don't forget the f of x out front. So that's how that's done. And again, it's just order of operations. I want to jump down to example number 4 where you do have an a. So order of operations are still in play here. So exponents have got to come before multiplication. That 3 is being multiplied by x plus 6 squared, but the exponent comes first. So we're going to leave the 3 alone for a minute, and we're going to take the x plus 6 times the x plus 6. Now, you could distribute the 3 through to that very first parentheses, but I don't want to confuse you. I'm going to go ahead and stick with the exponent first and multiply my x plus 6 times the other x plus 6, which is my exponent. So again, leaving the 3 alone, I'm going to get x squared plus 6x plus 6x plus 36. I'm going to combine my like terms first before I distribute. Now, I have to wait on this plus 5 until the very last, because addition and subtraction is the very last step that we do left to right in the problem. So now I'm going to distribute the 3. So I get 3x squared plus 36x plus 108, and then bring down that plus 5 finally. So to combine the 108 and the 5 would be our last step. So we get 3x squared plus 36x plus 113, and that is your final answer. But be careful with your order of operations when you do have an a. So that's how those are done. Let's jump over to standard form to vertex form. Now this is going to be very similar to your completing the square. Standard form to vertex form, number 1 says use opposite operations to move C to the left side. We want to factor out A if necessary from the ax squared plus bx. Then we're going to complete the square If you factored out an a, multiply the number being added to the left side by a. And that's the tricky one, which I'll explain in a minute. Number 4 says to factor the perfect square trinomial and combine your like terms on the left side. And then lastly, we want to use opposite operations to move the new constant back to the right side. So let's look at example number 7. Number 7 says f of x is equal to x squared minus 8x plus 15. And again, step number 1 says to use opposite operations to move the c to the left side. So the positive 15 is going to go over with the f of x. We want to just kind of get him out of the way. We don't want to deal with him right now. So we're going to move in by using subtraction. I'm going to leave a little space here. Because remember with completing the square, we add something to both sides. We're going to continue that theme. That's an 8x. So we move the 15s. Number 2 says to factor out a if necessary. We do not have an a other than 1, so we're good. Now we want to add that b over 2 squared to both sides. So negative 8 squared, negative 8 divided by 2 squared. Negative 8 divided by 2 is negative 4. Squared is 16. So we're going to add 16 on the right side, and we're going to add it on the left side. So that's the step that's similar to completing the square. The right side is now a perfect square trinomial. So we're going to factor it into that binomial squared. X minus the square root of 16 is 4. We can go ahead and combine our negative 15 and our 16, which gives us a positive 1. And then we're going to move that 1 back to the other side using opposite operations. So now our equation says f of x equals x minus 4 squared minus 3. The directions do tell us to state the vertex and the axis of symmetry. So the vertex would be, remember how the h lies to us. So if the vertex form of a quadratic is f of x is equal to a times x minus h squared plus k. If there is a minus here, what sign does that 4 actually have attached to it? Well, it's a positive 4 because the minus is in the formula. So in order for that to be a minus, which it is, the 4 is a positive 4. So the vertex is at 4, negative 3, and our axis of symmetry is x equals 4. Let's look at another one. Let's look at number 9. Now, number 9 has a coefficient on the x squared. So we're going to have to deal with him in just a second. But the first step is to use your opposite operations to move the c. So I'm going to add the 15 over with the f of x. The next step says to factor out a if necessary from your ax squared plus bx. So it is necessary. I need to remove the 2. And I'm left with x squared plus 4x. And I'm going to leave a little space. Because in the next step, I'm going to try to complete this square. So we're going to take the b that's on the inside of the parentheses, which is 4, and we're going to divide that by 2, and we're going to square it. So that means I'm going to add 4 here. Now, what do I need to add to the other side? It's not 4. If you look here, there's a 2 attached to this parentheses. So this 4 is not just a 4, it's an 8. So we have to multiply the 2 times the 4, and that's what gets added to the other side, which is an 8. And that's the confusing part about changing from vertex, our standard form, back to vertex form, is that what we add to the left has to match what we've added to the right. And in this problem, because we factored out a 2, that's not just a 4, it's actually an 8. All right, so now what we want to do, I'm going to combine my 15 and my 8, and I'm going to get a positive 23 equals. I'm going to factor, the 2 stays. Now my trinomial is a perfect square trinomial at this point, and it's going to factor in an x plus 2 squared. And then the last step is to subtract that 23. So we get f of x is equal to 2 times x plus 2 squared minus 23. We've changed our equation from standard form to vertex form. And the vertex here is going to be a negative 2 and a negative 23. So that's the ordered pair for the vertex. And the axis of symmetry, I'm going to label it this time. The axis of symmetry is going to be x equals negative 2. And that's an equation of a vertical line. I'm going to do one more of these that has a leading coefficient just to make sure that you are good with what's going on. I'm going to choose to do number 10. Number 10 doesn't appear to have a number in front of the x squared, but it does. It has a negative 1. Now, some students may be asking, why can't we just divide everything by negative 1? Well, if we're going to divide everything on the right side by negative 1, we have to divide the left side by negative 1 as well. And we cannot divide f of x by negative 1. It doesn't work that way. F of x is the name of the function, and we can't divide it by negative 1. It's almost like it's not a true equation, in that we can't use functions, we can't use operations like add, subtract, multiply, divide with the f of x. Now, I do in the first step where I add the 12, but y'all, all I'm doing here is I'm getting the 12 out of the way of the right side, and I'm having to move it back later. So it's not like I'm combining it with the f of x. I'm just moving it out of my way. So I have this negative x squared minus 8x. Now, in the next step, I need to factor out that negative 1, and I have x squared plus 8x. And I'm going to leave me some space. Now, b is 8, divided by 2 is 4, squared is 16. So I'm going to add a 16 inside. Now, that's the easy part. But what do I add to the left side? 16 times negative 1 is negative 16. So really and truly, I'm taking 16 away. And then on the left, we're going to combine 12 minus 16. I don't know why I keep putting minus or equals. 12 minus 16 would be a negative 4 equals. I'm going to go ahead and factor. And I get x plus 4 squared. And then the next step is to add the 4 to get your f of x alone, by itself. And you don't need that 1. I keep putting it for some reason. But it certainly isn't necessary to have it there. There is a negative in front of that parentheses. And then your vertex is going to be negative 4, 4. And your axis of symmetry is x equals the negative 4. So those are your notes for lesson number 4, quadratics, standard, and vertex form.